Hi, and welcome to Chapter 12. Congratulations, you've made it. This is the last chapter that we're going to be doing for Math 127. We have four sections, 12.1, 12.2, 12.3, 12.5. They're all fairly short sections. Unfortunately, it's a lot of formulas again, but I'll kind of present you with the formulas. Some will do examples, some, we'll just kind of look at what the formulas are, give them to you so that if you encounter a problem with it, you can just apply the formula, but nothing really groundbreaking here. So the first section, 12.1, and this is on sequences and summation notation. So actually, all the sections we're going to be looking at here in Chapter 12 have to do with sequences and this summation notation. So first off, as is usual, I can give you guys a definition. So the definition of a sequence is as follows. So a sequence is a function f whose domain is the set of natural numbers. So our natural numbers are what? Those are our counting numbers. So 1, 2, 3, 4, 5. Those are going to be the values of our domain, the values that we're plugging into these functions. So the terms of the sequence are the function values So if we're just using the counting numbers and putting it into the functions, what do we get? We get f of 1, f of 2, f of 3, and so forth. So whatever our function is, we're just plugging in those values. So to save some time with the writing, we use the notation A1, A2, A3, and so forth, all the way up to AN. And these are the function values. So F1, instead of writing f of 1, we just write A1. Instead of writing f of 2 is equal to something, we just write A2. It's just a little shorthand notation for us. So let's look at an example here. So let's say we want to find the first 5 terms and the 100th term for the following function. A of n is equal to 2n minus 1. So the first 5, so the first one that we want is A1. That's our first term. So what happened here? Instead of AN, we plugged in a 1 for n. So that means in our function, we're going to do the same thing. Anywhere we have an n, we're going to replace it with a 1. So this is 2 times 1 minus 1. 2 times 1 is 2 minus 1. So 2 minus 1 is equal to 1. A of 2 is equal to what? Well, now we've replaced the n with a 2. So 2 times 2 is 4, minus 1 is 3. Excuse me. A3. So that's 2 times 3 is 6 minus 1 is 5. A4 is 2 times 4, which is 8, minus 1 is 7. And A5 is 2 times 5, which is 10, minus 1 equals 9. So that's our first 5 terms, A1, A2, A3, A4, A5, and then it wants the 100th term. So it wants A100. So that's just 2 times 100, which is 200, minus 1 is equal to 199. So that's if we're given our function, we want to find a specific term. So let's look at an example. So let's assume instead now we want to find the nth term of a sequence. So it's basically going the reverse. So now we're given these values and we have to generate what is the sequence, what is this function that would generate these values for us. So here's an example of something like that. Let's say we want to find the nth term of the following sequence of numbers. The first number is -2. The next number is 4. The next number is -8. The next number is positive 16. And the next number is -32. So the first thing we need to do is figure out what's the pattern here. What's happening from this? If this is our A1 and this is A2, what do we have to do to get from A1 to A2? Well, basically we have what? Our addition, or we have multiplication or division or subtraction, our 4 operations. So to go from -2 to 4, I would have to add 6. But if I add 6 to 4, that does not get me -8. So what's happening is I go from -2, if I multiply that times -2, it gives me +4. +4 times -2 is -8. -8 times -2 is +16, and so forth. So we found the pattern. We start with A1, that value is -2. Then each successive time, we're multiplying it by the -2 from the number before it. So let's look at this too. Our A1 is negative. A3 is negative. A5 is negative. And then our even terms, A2, A4, those are positive. So we have to account for that as well. So once we take all this into effect here, the formula that we can generate to get this sequence would be as follows. -1, because I'm going to be switching from positive to negative. And then I have multiples of 2. But don't forget, I have to have my value of n so that when I plug in 1, I get a -2. So that means what? So A1 is -1 to the first power and 2 to the first power. A2 is what? Well, it's -1 squared, because that's +1, and then 2 squared is equal to 4. So +1 times 4 is 4. So you can see the pattern that's developing to where we eventually get to A of n, which is what we want. The nth term is -1 to the n times 2 to the n. So that's all we're doing if we're given a sequence of numbers and then we have to generate the formula from that. We got to try to pick out these different patterns, see what's going on with them, so then we can generate this equation. So that's the end of the first video. I did neglect at the start to tell you there's actually 2 videos for this section. So this was video 1 of 2. Come on back, we'll look at a couple more sequences, a couple more summation formulas, and that'll wrap up section 12.1.